right, so this video is to help you get more comfortable with writing equations. So we're going to kind of guide you through the process using the concept of rate of change we talked about in the last video. So first, we're going to complete any missing values in the table. We're going to find the rate of change for the table. And then we're going to highlight the ordered pairs in the table where the x-coordinate has a value of 0. So using these two steps, that's going to help us finally come up with our equation. So when I'm looking at my table, the first thing I'm going to do is start noticing what's happening here. So this one is increasing by 1, this one by 2, this one by 2, and this one by 2. This one is increasing by 4, this one is increasing by 4, and this one is increasing by 4 as well. So every time it increases by 2, it increases by 4. But this one's only increasing by 1, which is half of 2. So this one should be half of 4. So working backwards, if it was supposed to be an increase of 2, then that means it had to start out further behind. So I should subtract 2 to get my answer. So my rate of change is always found by putting my y over my x, because that's going to help us simplify it, to figure out our graphing, and that's what you'll be using in algebra. So it's always going to be whatever our change in y is over our change in x. So looking at that, I've got 4 and 2, 4 over 2, so we're comparing these ratios, and I've got 2 over 1. Those are the two values that differ. But if you look at it, 4 over 2 simplifies to 2 over 1, which are equivalent ratios, which is what we talked about last week. So our rate of change is 2 to 1. So y changed 2 for every time x changed 1. This is important because that's what gets multiplied by x when we write our equation. So we have y equals, and we're going to do an x. So there's going to be something in front of the x, and sometimes there'll be something following the x. This rate of change tells you how much the variable changes. So it goes with the variable. 2 over 1, of course, simplifies to 2, so it goes in front of my variable, because 2 times x, that describes my change. The other part comes from this third step. It says highlight where it's 0. So where it's 0 is minus 3, and that's what goes there. Now, if you think back to when we did our sequences, this is actually how we determined our sequences. We said, okay, how much is it changing by every time? And that's what we multiplied by our variable. And then we started plugging in our variables to see what it was supposed to equal. And our graph told us -3. So, sorry, I'm plugging in the wrong one. -1. So then we figured out, how did we get from +2 to -1? Well, we subtracted 3. And we plugged in, say that our next value is 3. And we knew that our table told us that was supposed to be 3. So this was 6. How do we get to 3? We subtract 3. So these processes that we've been talking about all year have been related. But now we're moving on to a more algebraic sense, and we're talking about our rate of change. Goes with our variable, because that's how our variable is changing. That's why it's called a rate of change. And then this value is actually your starting point, where it starts at 0. So this is also why we talked about proportional versus non-proportional, and we said from an equation it was non-proportional if something was added or subtracted, because that meant it didn't start at 0, 0. So let's try another one, because I know that was a lot of information. All right, so this is increasing by 1, this is by 2, this is by 1, and this is by 2. This one we don't know yet. This is by 10, this is by 5, and this is by 10. So for 10, it matched up with 2. Remember, it's always y over x. So it was 10 over 2. Which simplifies to 5 over 1. This was 5 over 1, which means my overall rate of change is 5 over 1, because 10 over 2 is also 5 over 1, which means that my very last number should be 5 over 1. So if I went from 0 to 1, I went from some number to 8. I went there by increasing by 5. So to move backwards, I subtract 5. So that means my starting value was 0, 3. So I'm going to highlight it. Now remember, the two important things when you are writing that equation, you're going to have a y equal some value of x. The value in front of the x is your rate of change. The value behind the x is whatever's highlighted with your 0. So plus 3. And you can check this by, of course, plugging in your values and seeing if it works. Example number 3. We are increasing by 8, and we don't know what's over here. We are increasing by 4 and 2. We are increasing by 6 and 3. We are increasing by 2 and 1. This is going to be where it's very important. You remember, y is always over x. So this is going to be a 1/2. 3 over 6 is also 1/2. 2 over 4 is 1/2. So now I have something over 8. Well, half of 8 is 4. So this should be a plus 4 increase. So when I go backwards, I'm going to erase this so I have a little more room later. When I go backwards, I was supposed to add 4 to get to 1, so I subtract 4 to get backwards, which means I should be at negative 3. So again, that was my value. 0, negative 3. I need to go and fill in down here. Now my rate of change, you always put it simplified, was 1/2. So y equals something with x. The 1/2 is with x because it's the rate of change. And then you need to figure out where it starts, which in this case is minus 3. So how did you determine the values of y when x was 0? Well, we found the change in y. For a change, sorry, got distracted for a second. For a change of 1 in x, and work backwards. So in other words, we looked at those rate of changes. How did you determine the equation? Our format was y equals rate of change, which you'll be given a special word for this next year, variable, and then we added or subtracted value of y when x equals 0. And we got this again from our table. Alright, so that's all we have for our notes today. There are a couple problem situations in your workbook that you should be working on afterwards.